Okay, once again, good morning. Welcome to our introduction to kinematics problems. For today, we will be solving horizontal motion. Okay, so just a review. In solving kinematics problem, all you have to remember is to ask if what is the acceleration of the problem. So if the acceleration of the problem is simply zero, so we will write acceleration is zero. All you have to remember is just velocity equals distance over time. Okay? So maoro gyud ni imuhang dumduman. Okay? Velocity equals distance over time. Some of tutorials they will prefer the triangle. Okay, this is the triangle. Okay, T and V C. So if you want to solve for the velocity, distance over time. If you want to solve for the distance, velocity times time. And if you want to solve for the time, distance over velocity. Okay, so that will be your first thing to remind of. Now, what if your acceleration is not zero? Okay, acceleration is not zero. It could be positive or it could be negative. Positive acceleration meaning increasing velocity. When you have a positive acceleration, meaning to say you have an increasing velocity. And when you have a negative acceleration, meaning to say you have a decreasing velocity. Okay, and of course, when you have an zero acceleration, meaning there is a constant velocity. Because by definition, when you say acceleration, that is the change in velocity. Acceleration is the change in velocity over time. Okay. So anyway, if the acceleration is not zero, so you will be memorizing religiously, wholeheartedly this four kinematic equations. So what are those equations? So first is the delta x, which is the displacement. Delta x is just VIT plus 1/2 AT squared. And the unit is in, SI unit is in meters. So initial velocity times plus 1/2 the acceleration and times squared. Second equation that you need to remember is the final velocity. Okay. So all you have to do is just differentiate delta x with respect to time, dx dt. So you will end up vi plus at. So this is the second equation. Third equation that you need to remember, another equation is the vf squared. Vf squared is just vi squared, the initial velocity squared, plus 2a times displacement. And lastly, another equation for displacement, delta x, is just initial velocity plus final velocity divided by 2 times time. So again, the question is asking, or the problem is asking, stated that the acceleration is zero. All you have to remember is this formula or this triangle. But if our problem has an acceleration, either positive or negative, remember this four, okay, equations. And from the given, okay, from the given, all you have to do is just pick kung asa aning upat ka equation ang mo fit sa imong given to solve for the unknown. Okay, let's have an example. Example problem. Okay, let's have this. Now, an airplane accelerates down a runway at 3.2 meter per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So first things first, if wala nimo na picture out ang problem, all you have to do is just plot or draw. So, unsay nahitabo sa problem? Assuming this is our airplane, of course, a normal airplane before it finally lifts off the ground, it will travel some time, diba? Muhunat sana yung airplane. Okay, until mulupad na siya sa langit. According to the problem, it accelerated for what? 3.2 meters per second squared for 32.8 seconds. So question, what is your distance travel before siya nilupad? So what is this distance? Okay, this is the distance that we are referring to. And another thing, of course, we can assume that this airplane is starting from rest. Of course, wala may airplane na mag-start na magdaganda. Ma-meet up ang nagpasahero ng airplane. Okay, at some point, makalingkod na tanan ng pasahero, it will travel from distance. Ay, siya mulupay. So we will assume that this airplane is at rest. So we already have the plot, okay, the visualization, the given, and the ano, okay, which is delta x. Now, all you have to do, if dili nimo ma-memorize ang mga equation, isunod na to tanan. Delta x equals VIT plus 1 half AT squared. VF equals VI plus AT. VF squared equals VI squared plus 2A delta x. And delta x is VI plus VF over 2 times time. Now, the question there is we are asked for the delta x. So, from these four equations, kinsay na ay delta x? Sa equation 1 na ay delta x. Sa equation 2, wala. So, we cannot use this equation 2. Sa equation 3 na ay delta x. Sa equation 4 na ay delta x. Now, from the given acceleration, kinsay equation nga na ay acceleration? Si 1 ay acceleration. Si 3 na ay acceleration. C4, walay acceleration. So, meaning to say, x na ning equation 4. So, it's either equation 1 or equation 2. Now, let's proceed. Kinsay na ay time? Time. For the times, equation 1 ay time. Si equation 3, walay time. So, meaning to say, we can use, okay, the perfect equation that we will use is equation number 1. Because from the given, siya mo'y pinakamatch. He match all the given. And also, he is the type of equation nga na ako'y delta x, which is mo na ang ato ang gipagita. So, meaning to say, delta x equals VIT plus 1 half AT squared. Now, plug in the values, delta x, muna siya itong gipangita. So, we are asking, initial velocity is 0, 0 times something is just 0. Sorry, na-plus ana. Plus 1 half. What is 1 half? Acceleration, 3.2. Time is 32.8 squared. Now, if you will use the now we will use the calculator. 0.5 times 3.2 times 32.8 squared, meaning 1,721.35, hindi ko kayo, 34. Okay, 34 meters. So, meaning to say, ang atong airplane, kung dagan sa siya, pinakadistansya, our airplane will run 1,721.24 meters before siya go larga or lumipad sa langit. So this is how we solve kinematic equation. So again, to summarize, first, if you cannot visualize what is the problem is talking all about, mo gina siya i-drawing. Okay, all you have to do is draw. You need to draw. So this will be our airplane. Atong airplane ni draw ani at rest, and nidagan siya for some distance ay siya nilipad. And based from the given, ang given sa tuwa is acceleration, time, initial velocity. And we are asked for what is this distance nga gidagan sa tong airplane. Now, from the four kinematic equations, since naaman tay acceleration, we will use these four kinematic equations based from our given, okay, and the question being asked, try to inspect asa aning mga equation siya mo fit in. And based atong inspection, we can use equation 1. Okay. And after inspection, meaning to say all our given will match this equation from this four equation, that's the time you will plug in the values here. Okay. Plug in mo values dire and just do some manipulations, and by the use of your calculator, you will end up with this answer. Okay, we will try to solve more problems. Okay.